Good morning, everyone. My name is Matthew Potter, and I'm the CEO of ALGA. And it is my privilege to welcome you all to the inaugural event today, ITRC and ALGA workshop working together on PFAS. So this will be the first of hopefully many workshops and collaborations that we'll have with ITRC. I thank you all for your attendance. Just to give you a bit of a rundown on the session this morning, and welcome to everyone online as well. We've got over 800 registrants online, and we've got about 40 in the room. So this morning, the plan will be, we'll do a short introduction. So I'll invite Dr. Sophie Wood, who will do acknowledgement of country and say a little bit about UTS. Then Patricia will do a welcome in terms of ITRC, and then I'll do a short introduction in terms of ALGA. We'll then have an hour session with 6 speakers, 10 minutes each speaker, and we'll allow for 15 minutes at the back end of the session for questions. I'll introduce our chair shortly as well, who will take you through a little bit more around the agenda and the program. But first of all, I'd just like to invite Dr. Sophie Wood to the stage. So Sophie is the director of the popular Contaminated Sites Assessment, Remediation and Workshop series of short courses at University of Technology. Thanks, Sophie. Which is aimed at providing comprehensive continuing professional development of contaminated land practitioners. She was formerly a New South Wales EPA accredited site auditor and contaminated land consultant. Thank you, Sophie.
Thanks, Matt. So I'm delighted to be able to welcome you all to UTS here this morning. We're lucky enough to be physically located in this marvellous Frank Gehry building in the business school at the UTS City campus. I'd like to begin by acknowledging the Gadigal people of the Eora Nation on whose land the City campus now stands, and pay my respects to their elders past and present. I'd also like to acknowledge the traditional custodians of the various ancestral lands from whom our other participants in Australia join us today, and pay my respects to their elders past and present also. So I'm very pleased to have been indulged by ALGA with a brief introduction so that I can spruik UTS and all its fine products. As you may know, we are Australia's #1 ranked young university, which is a ranking system for universities less than 50 years old. And we focus very much on teaching and research, which has direct and immediate benefit for industry and society. I personally run a series of contaminated land training courses aimed at industry regulators and consultants. And those are a series of 3-day short courses which run 5 times a year on various aspects of contaminated land and are lectured by a series of eminent practitioners in the industry, some of whom are speaking here today, and site auditors, academics, regulators who present copiously on various aspects of contaminated land. Those courses are extremely popular, have been running for 14 or 15 years, and I've only recently taken over them, so I don't actually bear any of the credit for having produced them. We also offer a variety of postgraduate and undergraduate environmental courses which are relevant for people doing all kinds of environmental careers, including contaminated land, but also water management, sustainability and general environmental management. And we have a specific environmental consultancy and ecology master's course, which is run out of the Faculty of Science, which actually includes 2 of my contaminated sites assessment and remediation short courses. So we have master's students and industry people in the same place at the same time, which is particularly awesome. We've also got a research team, the Phyto Lab, who specialise in phytoremediation, doing things like practical solutions for remediation of mine sites, petroleum hydrocarbons, oil spills, using plants and algae. They've recently written an article for ALGA's Chronicle magazine, which I'm very much hoping that you'll be able to see next month. When you read your copy of Chronicle, you'll find one of our PhD students showcased in there, and his project's very fine, so I encourage you to read it and learn all about what he's been doing on New South Wales mine sites. Okay, I've probably used up my time. I shall hand back over to Matt. Thanks, Matt.
Thanks, Sophie. Now I'd like to introduce Patricia Reyes. So Patricia probably needs no introduction, but Patricia is the Director of the Interstate Technology Regulatory Council, more commonly known as ITRC, and she's been that director since 2015. As the ITRC Director, Patricia oversees the annual budget of nearly 3.5 million, manages 4 staff and 18 contractors. Prior to joining ITRC, Patricia served as the presidential appointee and Senior Advisor for the Deputy Under-Secretary of Defence for Environmental Security, providing policy recommendations and strategic advice. Patricia holds a Master's in Public Administration on Environmental Management from the American University of Washington. Thank you, Patricia.
Thanks, Matt. Good afternoon and good morning for those in Australia. It's 4 o'clock in Washington, D.C., where we are located here. So as Matt just said, I'm Patty Reyes, and I'm the Director of ITRC in Washington, D.C., and many of you are familiar with ITRC on this line. Wow, this is impressive. We might break our Zoom line with over 300 participants. This is fantastic. And so many of you do know what ITRC is and who we are, but I just have a few quick slides on to tell you in case you don't know. So we are the state-led coalition that is working to advance innovative and best management approaches to environmental issues of concern to United States states. We're made up of members from all 50 states, many federal agencies, and industry, just like you in ALGA. We average about 1,500 members per year based on the number and the type of topics that we're addressing. And we are funded primarily through federal grants and industry membership funds. Next slide, please. This is just a snapshot of who our members represent this year. You can see we're about evenly split between state and federal agencies and industry. And we currently have 1,322 members, of which 605 are on the PFAS team alone. Can be on multiple teams, so there you can see the overlap there. Next slide, please. What do we do and what do we produce? Well, we are a creditable, consensus-based, we have a process that's consensus-based. We produce documents, videos, fact sheets, and what we're most proud about is our training classes. To date, we've trained over 160,000 people on over 90 topics. Next slide. These are the classes, the teams that we're going to either continue or start new in January. You can see that the 4 new topics are passive sampling technology. We've done that work in the past, but it hasn't been done in the last 20 years. We're focusing a lot in the United States on solid mining waste recycling, cleaning up our mines. We're also looking at a new emerging contaminant called 6-PPD, and that's for tire chemicals for anti-degradants on tires. And we're going to continue with our microplastics team with a focus on an outreach toolkit. The other teams have started this year and they will be continuing. And they all start in January. Registration opens in December. Everybody is welcome. And then we have 2 teams that are going to start in July. You can see those on the bottom. One is the contaminant mass and low permeability and heterogeneous matrices. And the other one is related to carbon emissions. So more information on those later in the spring of next year, and they'll start in July. Next slide. So I didn't want to take a lot of time because we have such exciting speakers and exciting questions to go through, but I want to make sure that everybody has access to our social media. Here are our logos. You can reach us anytime. We have all of our training schedules and our training classes there as well. Next slide. I think I'm going to turn it right back to Matt. Thanks, Matt.
Thanks, Patricia. Fantastic. So look, just a couple of slides from my end in terms of ALGA. So ALGA is a not-for-profit industry association representing all facets of the land and groundwater contaminated and remediation industry in Australia and New Zealand. We include members from a range of different areas and facets of the industry, including contaminated site owners, environmental consultants, remediation technology suppliers, remediation contractors, analytical laboratories, and industry regulators. So I think that's one of the unique factors of our association in terms of the end-to-end coverage across the industry as a whole. So established in 2007, ALGA provides a vehicle for sharing information and professional development across the industry. It has 8 board members or 8 board directors spread across New Zealand and Australia, 16 branches, and we've got a map for those that might be overseas and trying to understand in terms of where the locations are. 10 specialist interest groups. We also got a Brains Trust, and we've got a couple of members of the Brains Trust in the room today, 8 honorary life members. But again, we wouldn't function without our volunteers, and all up, we've probably got in excess of 400 volunteers across our branches, directors, and our specialist interest groups. In terms of membership base, we hold around 2,300 individual members, and we pick up as well around 58 corporate partners. So just in terms of, for those particularly overseas, the spread of our branches, we're really pleased to introduce a 5th branch in New Zealand for this year, and also to relaunch our branch in Darwin. And we'll be looking to have a symposium or regional conference up in Darwin in May of next year as well, which we're really excited about. Thank you. Next slide, thanks. So in terms of our specialist interest groups, I've got them listed there. There's a lot of overlap with ITRC and the working groups with ITRC as well. I would just encourage you, if you've got an interest in any of those particular specialist interest groups, to contact us and we can connect you in with each of those groups. A special mention, I suppose, to the emerging contaminants specialist interest group, and we've got the co-chairs in Charles Grimmerson and also Vicky Pearce, who can't be here in person, but hopefully is online, who helped facilitate this session today. And next slide, thanks. Just, I suppose, in terms of some of the areas that we deliver, I won't list them all there, but a couple of important notes just in regards to advocacy, also providing responses to our regulators in regards to guidance documents and legislation. In fact, at the moment, we've got our PFAS that we're documentation that we're also providing response to at the moment. Networking, which is important, and knowledge sharing. And this is a perfect example of the sort of events that we hold to ensure that that information is imparted to everyone. And then finally, just in terms of research collaboration. So as we mentioned, it's a privilege to be able to utilise these facilities and to build relationships with UTS and other researchers. So now I'll just get to the formalities. So I'd like to introduce our chair for the session today, Dr. Danielle Torres. So Danielle is the contamination manager at Sydney Airport. Danielle's professional experience spans across academic research, regulation, remediation, contracting, consulting, and client-side sectors. Her doctoral thesis focused on the adaptation of remediation technologies for use in cold, remote environments, including Antarctica. However, she has spent the last 6 years of her career focused on the investigation, remediation, and management of emerging contaminants. Thank you, Danielle.
Thank you. Good morning to everyone joining us in person, and good afternoon to those joining us online. I might invite our local speakers to join me up at the table. And I'll quickly just recap the format before we jump right in. So as Matt mentioned, we've got 3 themes today. Each of our 6 speakers belongs to one of those 3 themes. I'll be hopefully asking each of them 2 questions. And then with any leftover time, we'll revert to the audience to chime in with any questions that you might have. If you're attending in person today and you'd like to ask a question, the easiest way to do that is to write it on a Post-it note, jot it down while it's fresh in your memory, and they'll all get passed forward at the end. If you're joining us online today, please feel free to put your questions in the chat box. We won't be asking them in real time, but if we finish early, we'll ask them at the end as well. Cool. All right, so I might dive straight in and jump into our first theme, which is regular. Oh, okay. Cool. All right, so we'll jump into our first theme, which is regulation, and I'll introduce our 2 specialists for this theme. So joining us from the US is Kristi Herzer. Kristi is an environmental analyst and technical program lead for the state of Vermont's Department of Environmental Conservation. Kristi is a project manager in the Brownfields program and the sites management section and promotes the BRELA program. Kristi is also a division representative of the VTDEC's Environmental Justice team, an active member of a cross-agency PFAS working group and co-author of multiple guidance documents for the regulated community. Since 2017, Kristi has served as a member and subgroup leader for the sampling and analysis group of the ITRC and PFAS training team. And Kristi holds a Bachelor of Science in Physics and Biology and a Master's in Environmental Engineering. And from Australia, we have Andrew Mitchell joining us. So Andrew is an environmental engineer with a Master's in Public Policy, and he has more than 25 years experience in contaminated land management, including stints working on the Sydney 2000 Olympics, within the New South Wales EPA, working on the Defence PFAS program, and his diverse experience has helped him to understand the different drivers and perspectives of regulators, land managers, industry, and consultants. And he currently leads the National Environment Business in ADE Consulting Group. So please welcome our 2 regulatory experts. All right. All right, so Kristi, I might start with you. And my first question for you is, how do state PFAS guidance and regulations coexist with federal guidelines and standards?
Sure, yeah, we can hop to the states. PFAS regulatory values and criteria vary between programs due to the selection and interpretation of different key toxicity studies, exposure assumptions, choice of uncertainty factors, as well as approaches used for animal to human extrapolation. Some key state programs for PFAS as of this past summer are product labeling, consumer protection laws, as well as designation as hazardous waste or hazardous substances. States are and had been leading the way on regulations. The first action many states took was looking at drinking water, primarily focusing on PFOA and PFOS, but there have been other perfluoroalkyl acids and GenX, as well as a number of precursors that have been regulated. Many states, a number of states have passed legally enforceable drinking water standards, as well as a number of other different regulations regarding consumer products, surface water, soil, and many others. So states can choose to adopt the federal regulations, or if their state allows, states can be more restrictive and have more protective measures. However, states cannot be less protective than the federal government regarding PFAS regulation. For instance, in drinking water, Vermont currently regulates the sum of 5 PFAS at 20 parts per trillion, which is a maximum contaminant level, which I can get into. It's a legally enforceable standard. And at this time, 18 of our 50 states do have at least one type of promulgated legally enforceable standard for PFAS in drinking water. And these standards can apply to more than just one PFAS. Several states have promulgated standards for PFAS in multiple different environmental media. For instance, Michigan has promulgated standards for PFAS in surface water, drinking water, as well as groundwater. New Jersey has separate promulgated standards for PFAS in drinking water, groundwater, and just last month published interim soil remediation standards. ITRC has a really great resource that's updated approximately quarterly with all state and federal regulation and guidance values for drinking water, groundwater, soil, surface water, and effluent. It's called our soil and water values table, and I can drop the link in the chat box.
Okay, so that's a really good overview. And it kind of leads nicely into our second question, which was, where do you think federal regulations and guidance will head in the sort of next 1 to 2 to sort of 5 years?
Absolutely. So just sort of an overview, in the United States, we have the Environmental Protection Agency as well as the Food and Drug Administration. They both have regulatory or guidance initiatives for PFAS. Federal PFAS regulations are primarily under the purview of the Environmental Protection Agency, or EPA. There are other federal agencies and programs that are actively involved in PFAS related matters, but as far as regulations are concerned, I'll be focusing my time on the EPA. And as far as semantics are concerned, when I'm talking about regulations, I'm talking about requirements that have gone through a formal process to be promulgated and are legally enforceable, whereas guidance, advisory apply to all other policies and numerical values. And so for some context, PFAS was identified as an emerging contaminant in the US since the early 2000s. In 2006, the Environmental Protection Agency, EPA, rolled out the PFOA stewardship program to phase out production of PFOA from the remaining 8 manufacturers by and PFOA precursors by 2015. In 2019, and then updated in 2020, the EPA issued a PFAS action plan. And the focus of this action plan was establishing maximum contaminant levels, which I mentioned a little bit earlier, for PFOS and PFOA in drinking water. Again, these are legally enforceable standards. They describe the highest concentration of contaminant that's allowable in drinking water. These are set as close as feasible, both cost-wise and technology-wise, to maximum contaminant level goals, which are non-enforceable public health goals that there's no known or expected risk to health. So MCLs are legally enforceable standards. And last year, 2021, EPA published the strategic roadmap, the commitment to action from 2021 to 2024. So focusing on research, restriction, and remediation, and it lays out initiatives across different divisions of EPA, and there's far too much to cover, so I'll just focus on a few key points. Under the Federal Safe Drinking Water Act, there are no legally enforceable drinking water standards for PFAS yet. There are various guidances and advisories within EPA's different programs. For instance, the 2009 provisional health advisories for PFOA and PFOS were updated in 2016 to lifetime health advisories, 70 parts per trillion for the sum of PFOA and PFOS. Just this June, the EPA released 4 drinking water health advisories, interim updated health advisories for PFOA and PFOS, and final health advisories for GenX and PFBS. There's also the Unregulated Contaminants Monitoring Rule, UCMR. This requires public drinking water systems to periodically test for certain chemicals in drinking water that aren't otherwise regulated. So this next round, the Unregulated Contaminant Monitoring Rule, is testing between 2023 and 2025. It'll provide new data that's critically needed to improve EPA's understanding of the frequency and concentration that 29 PFAS are found in the nation's drinking water systems that serve 3,300 customers or more. So, in getting to your question, within 1 year, looking at the PFAS strategic roadmap, just a couple of key points. Fish monitoring in freshwater lakes started this summer, and so within a year, EPA is expected to publish a list of PFAS for state and tribal fish advisory programs that are either known or thought to be in samples of edible freshwater fish. There's the final rulemaking to designate PFOA and PFOS as a hazardous substance under the Comprehensive Environmental Response Compensation and Liability Act, CERCLA, or Superfund. And the US EPA method 1633, which is a draft, is expected to be finalized within the next year. Then looking 2 years out, hoping for the final national primary drinking water regulations for PFOA and PFOS, as well as guidance published on destroying and disposing of PFAS and PFAS containing materials. And then further out, 5 years, or as far out as the roadmap will go, EPA does plan to make significant progress on effluent limitations guidance by the end of 2024. And in that 5-year time span, EPA will have the data from the unregulated contaminant monitoring rule to review, determine if any of the new chemicals that were quantified have occurrence levels where they need to be addressed. And unfortunately, the roadmap does only go to 2024, so I can't quite predict out to 2027.
Crystal ball doesn't go that far. That's some really interesting points there and some really interesting differences between what's happening here in Australia. Very interested to hear more about the unmonitored contaminant rule and what the findings of that is in a few years' time. I might hand over to Andrew. I'm going to ask you the same questions, and in your response, it'd be really interesting if you might touch on some of the differences potentially between the Australian approach and the US approach. Do you want me to remind you of the questions?
No, thanks, Danielle. I'm fine. So, first, I just need to give a disclaimer. I'm not a regulator, and I have no special knowledge of the future of regulation in Australia. I'm a practitioner, and I struggle with implementation of guidance. So, I'm sharing a few thoughts and principles and lessons I've had from that struggle. So, for our American friends, Australia is like the US in that it's a federation of states. So, under our constitution, the states have responsibility for environmental protection, and the Commonwealth can only step in on matters of national environmental significance. So these are actually currently up for debate, but they don't include PFAS or any other contaminant in the environment, and we have no federal EPA. So it's the states for implementation. But what we do have is a very well-functioning informal collective of state and territory environmental regulators, together with the Federal Environment Department. And they call themselves the heads of EPAs, or HEPA. So the National Environmental Management Plan for PFAS has been published by HEPA. Version 1 came out in 2018, 52 pages. Version 2 in 2020, 134 pages. And version 3 has just come out for public consultation, 214 pages. So each state or territory then implements the NEMP, as we call it, in their jurisdiction, using the various powers to recognise external guidelines. So it's supposed to be nationally consistent, but it isn't really, because each state have their own drivers, their own regulatory frameworks, their own overlay, their own politics, and their own personalities. With respect to drinking water, that is nationally consistent. There is an Australian drinking water guideline. PFOS, PFH excess and PFOA are in it, and it's implemented very consistently by departments of health and water utilities. In Australia, typically PFAS is not an issue in drinking water. It's more of an issue in ecology, ambient environments, and soils.
Okay. And where do you think it's going to go in the next sort of 1, 2, and 5 years?
That's the question I love. So let's just have a little, please bear with me while we do a little background on what is regulation and some of the principles behind it. Because I cannot tell you what it will be, but I can paint versions of the future, some of which may be attractive and some may be less attractive. So what is regulation anyway? Malcolm Sparrow is a deep thinker in regulation. The EPAs in Australia have paid a lot of attention to his training. So he says that the whole point of regulation is that the government needs to intervene for the public good when market forces and private incentives do not naturally combine to serve the public interest. So the environmental context, this is about addressing a market failure, usually due to negative externalities. So that's like a harm that arises from the main activity that is felt by others, not the person carrying on that activity. So what's a market failure with PFAS? It's a contaminant like many others. We have lots of rules for many other contaminants. What's special? So it's a surprise, if you like, and that is a class of chemicals that's more persistent than thought. It's more bioaccumulative than thought. It's ended up in places that were not expected. And that's probably the main thing. People test for PFAS in strange places and they find it. They go, holy cow, that's a problem. What should we do about that? So without government regulation, there would be no driver to clean up contaminated sites, nothing to stop people training with AFFF that contains PFAS. and no other controls. So we need regulation. But it's not as simple as just banning chemicals and setting low guideline values. Credible regulation is difficult, and evidence-based or risk-based regulation is really difficult in a space with significant uncertainty. With the exception of chlorofluorocarbons, CFCs, the timeframe to manage new contaminants is measured in decades. So what we did with CFCs in the late 80s, early 90s globally was amazing. That was the outlier. PFAS, like other contaminants, is taking a while. So there's some principles behind credible regulation. There's a lot of research in the space, mainly focused on avoiding perverse outcomes. So let's look at a few. We're familiar with the precautionary principle. We've learned some hard lessons from that with respect to, say, tobacco or climate. We must not use a lack of complete knowledge as an excuse to not act. So regulators are acting, which is a good thing. But there's a couple of other principles that we hear of a bit less often I'd like to introduce. So according to Ari Freiberg, as an Australian academic in regulation, proportionality is a concept that relates means to ends. So in government action, it generally means that the intervention employed should be that which is necessary to meet the regulatory objective, that the means used are no more than is necessary to achieve that objective. And the principle of parsimony holds that a measure or intervention should not be more severe than that which is necessary to achieve the purpose for which the measure is designed. So the rationale for parsimony is twofold. It's economically efficient, and it avoids unnecessary or possibly disproportionate infliction of harm. So Freiberg concludes that connected with both of these principles is the idea that a measure to be taken in response to a risk should be the least restrictive of the rights of the person. So just bear that in mind as I move on. So these principles, I fear, are not always well implemented in PFAS regulation around the world, including in Australia. So how does PFAS regulation hold up to these principles? People talk about the pendulum of regulation swinging backwards and forwards. There's a strong driver from community outrage, a strong driver from politics, and these are good and appropriate. If it was not for community outrage and politics, we would not have clean air or clean water that we do now. So these are good things. But what is happening in the space of PFAS regulation? Let me ask you some questions. How much of your freeway budget should be allocated to managing PFAS in the road corridor as opposed to on the other side of the fence? Who is responsible for managing PFAS in compost when our recycling sector is already under so much pressure? What is a small town to do with biosolids that are above relevant guidelines? They have a landfill. The leachate from the landfill goes back to the sewage treatment plant, and PFAS is going around in circles. So what is society's willingness to pay for PFAS management in addition to all the other competing demands that we have right now? So I'm thinking that the regulatory sector will struggle for a few years with implementability of guidance. We have guideline values built on toxicology with large uncertainty factors that have led in some cases to trigger values that are less than ambient. So we have rainwater that's not safe to drink. We have, some jurisdictions have in effect banned compost because the limit for compost is below the lowest measurable limit in any compost in that state. Should all this compost go to landfill? Should it be incinerated? Or maybe it can be beneficially reused in appropriate circumstances. When everything is bad, how can we prioritize solving the problems? A huge amount of money has gone to consultants and contractors to intervene with PFAS where there's been no measurable, tangible improvement. Future regulation needs to provide the tools to address the big problems, but tolerate the small. So what is big, what is small? I'd suggest that we need a test for meaningfulness prior to intervention. Let's try to focus the investment of limited resources into solving problems that matter. So a couple more points. Chemicals regulation, I think, is a key. We're largely environmental contaminated land people. The chemicals regulatory people are usually in a different room talking about different things, but I think they're really important to this conversation. Take your mind back to the year 2000 when PFAS was removed from Scotchgard and other household products. In the US, human blood levels dropped from about 30 parts per billion on average in 2000 to about 5 in 2013, just 13 years to drop by a factor of 6. That is amazing. It shows the power of chemicals regulation. But the chemical sector is really smart. You can swap a chlorine for a fluorine, you can add an ether bond, and you turn PFAS into F53B, which is like PFAS, It may be as toxic as PFAS, it may be as persistent and bioaccumulative as PFAS, but it's not PFAS and not subject to PFAS regulation. So you can't regulate one chemical at a time. The chemicals industry will always be ahead. So I see the chemicals regulation sector as bringing in a class approach to regulating PFAS. But I don't see that happening with contaminated land or water treatment, because the toxicology is really difficult. It's really challenging to come up with guidelines or a class. I'd like to see that happen. I think it'll be challenging in the next 5 years. Rather, I think we need more than in Australia. We have 3 chemicals that are regulated, 3 PFAS largely nationally. In a few jurisdictions, we have other PFAS. Mainly, it's the big 3. We need more than that because that's telling some people that it's okay to discharge short chain PFAS, or it's okay to have fluorotelomers in the environment. And I'd suggest it's not. I suggest that we need to take a proper look at the context of the situation. In addition, I'd suggest that the top assay and leachability testing are sometimes not very well applied. So where should we end up? Where should we go? I'd suggest that when PFAS regulation is mature, we'll have a way to not sweat the small stuff. We'll be able to tolerate ambient contamination. We'll be able to move on to the big things and solve those. A simple method to solving the big things is, work out what's the biggest, what's the highest contamination, the worst source of PFAS, fix that, tell everyone about it, measure the effect, what does the average drop to, and then rinse, repeat, do it again until you don't see any more improvements. And then you can't make any more improvements. That's when you need other tools, such as chemicals regulation, to address the issue. Lastly, I would say that you ensure that whenever you make an intervention, whenever you make an investment, you have a way to improve. But you have a way to measure the improvement that you make. Let's stop spending money on PFAS remediation where we can't actually tell if we've achieved anything in the end. That's, I think, all I have to say at the moment.
Okay. Very interesting thoughts there. And I can tell people are very interested because I'm seeing a lot of post-it notes being filled up. So I'll try and move us along to make sure we've got time to get back to those questions. So we might move on to theme 2, which is all about remediation approaches. And I'll introduce our 2 specialists in this space. So with us in person today, we have Dr. John Hunt. So Dr. John Hunt has more than 30 years experience in contaminated land assessment and remediation, and he's worked on some of the most complex remediation projects in Australia. He's worked for a wide range of clients at gasworks, hydrocarbon contaminated sites, chemical manufacturing sites, munitions manufacturing sites, radiological sites, PFAS contaminated sites, boatyards, landfill sites, and infrastructure sites. And prior to his career as a CLM expert, he was a senior geologist with Delhi Petroleum and Esso Australia. And he was also a geologist with the CSIRO Field Geoscience Unit and an environmental planner specialising in geological resources and hazards. Dr. Hunt's special contribution to the field of remediation is problem definition, which is really the interface between assessment and remediation design. He also has a special interest and expertise in remediation sustainability. And joining us online from the US, we have Bill DiGuiseppi. Bill is a 30-plus year experienced principal hydrogeologist with Jacobs in Denver. He's an expert in the history, occurrence, and remediation of PFAS and 1,4-dioxane, having assessed these contaminants at hundreds of sites. Bill frequently conducts 1,4-dioxane and PFAS training for a variety of groups, including the ITRC, US EPA, US DOD, US DOE, and the Society of American Military Engineers. Bill has been actively engaged with the ITRC PFAS team as the Treatment Technologies Writing Subgroup co-lead. He's a content trainer and roundtable panelist. His enthusiastic support of the ITRC earned him the 2018 Industry Member of the Year Award, which sounds like he was very deserving of. And Bill is also an adjunct faculty member in the Civil and Environmental Engineering Department of Colorado School of Mines. Please make them both welcome. So Bill, I'm going to start with you. And my question for you is, what approaches are being applied to the remediation of PFAS in soil, drinking water, and groundwater?
Thank you, Danielle, and good to see you again, even if it's virtually. John and I had talked about divvying this up by media somewhat. So I'll focus on drinking water and groundwater, and then John will cover soil and solids. Related to drinking water, one I think important factor to consider between US and Australia is in the US, close to 50% of our drinking water comes from groundwater. And in Australia, that's more like 5 or less than 10%. I'm not for the exact numbers, but over 90% of your drinking water comes from surface water. So the bulk of our drinking water is actually treated groundwater. And there are a number of technologies that have been well demonstrated and are in use right now. And the main one is granular activated carbon, fully commercialized, available, multiple vendors, large scale systems, fully employed and functioning. The second runner up would be ion exchange media, both single use and regenerable ion exchange media. Predominantly the single use media, and that's used also in large scale drinking water systems, but not quite as much as granular activated carbon. And I think there's a lot of other technologies I'll sort of touch on, but one of the key things is simplicity and surety. So carbon it's not quite perfect, but nothing really is perfect. But it is simple to apply. The engineering.
Oh no.
Yeah, sorry.
You have.
Hello? Okay. Are y'all hear me fine?
Yes,
Yes,
Bill, we
it's
can
all
hear
good.
you.
Okay. Sorry, I don't know what's going on. Anyway, so those two media are easy to apply and widely used. Reverse osmosis has good functionality. It is employed some for drinking water, but not really as much as the other simple media. Usually that's due to maintenance and energy costs. But one of the key things for drinking water in the US is any technologies being used have to be certified by the National Sanitation Foundation. NSF certification is a requirement for us. So none of the other technologies that are being experimentally applied elsewhere are yet certified. And so there will be some time lag before those demonstrate sufficient capability to be used in drinking water. So then related to groundwater itself in terms of groundwater treatment, really relatively little groundwater treatment has occurred in the US. The really big programs have been plodding along at their typical pace, but it takes time to do the investigation and evaluate what exactly needs to take place and where and how much and all that. And the standards are changing rapidly in the US. So the US Department of Defense, for instance, has done some drinking water treatment for the on-base drinking water supplies, and they've also funded and implemented drinking water treatment for surrounding communities. But they haven't really done much in the way of groundwater treatment yet because they're still in that investigation phase, which is really where Australian Defense was 2 to 4 years ago or so in terms of understanding what the problem is. So not a whole lot of groundwater remediation like site remediation has occurred in the US. What has been done has dominantly been containment systems, pump and treat to prevent migration off-site. And that's usually with carbon or ion exchange as well. There are a number of technologies that have been field pilot tested in the US, electrochemical oxidation, the cold or non-thermal plasma, supercritical water oxidation, foam fractionation in the US. None of those have been implemented as a permanent long-term solution. All of those have been tested and proven to be effective, but not as a permanent long-term. And then there's a number of others that are sort of bench scale technologies, electrolysis, sonolysis, electrochemical precipitation, things like that. Those are all sort of at the academic level or vendors on the bench scale working their way towards a field pilot test. But I do think what we'll see in the US is substantial change in the next 2 years or so as more decisions are made that remediation might be warranted. And the one last thing I'd add is the injectable technologies. You all might be familiar with some of these powdered activated carbon polymer type technologies. There's a lot of research going on with that as well. That also has been done. That's actually been done for PFAS, full scale, permanent solution more or less, but as a containment barrier to prevent migration of PFAS. So that's kind of it for the water side for the most part. So John, you can jump in on the soil.
Thanks, Bill, it's good to be here. In Australia, I'm going to talk about Australia and the US because Bill has sent me some notes, but in Australia, there are quite a few approaches available for dealing with PFAS contamination, and basically we've just taken what we already knew how to do and applied it to PFAS. What is actually done site by site depends on a number of parameters. One is the quantity that you have to deal with, because obviously with a small quantity, there are a lot more options available because the costs won't be that great overall. The second is the concentration of the PFAS in the soil, because concentration will be subject to regulation, both state and federal. And the third is the land use that you're dealing with. By their nature, many PFAS sites are operating sites, so they have constraints on them in terms of what you can do as opposed to what you'd like to do. So considering soil, first of all, I would note that on many sites, soil has been stockpiled over the last decade in the absence of kind of ready solutions. So just put that in the back of your mind. And that's generally because those sites are operating sites and there are continual site works occurring in terms of new buildings and infrastructure and services and that sort of thing. And they're generating small amounts of soil on an ongoing basis. For sites with small quantities, generally the soil is sent off for either treatment or landfilling. And I'll deal with treatment shortly. Landfilling, we actually have landfill criteria in the National Environmental Management Plan for PFAS, but New South Wales jumped the gun and actually had their landfill criteria in place before the NEMP was put in place. So we have different criteria in New South Wales that are more stringent, just to make things complicated. In terms of sites with large quantities of soil, and we're talking mainly operating sites here, the usual sorts of solutions for those sites and other contaminants have been capping or encapsulation, and basically that is happening for PFAS as well. That's also a solution that's being implemented in the US. Very low concentrations are simply being managed on site as opposed to any site works, of course. Most sites will have a range of concentrations on the sites. The high concentrations will be in the source areas. And I'd have to say, being new to the PFAS space as of this year, I was a bit surprised to find that some sites have well over 50 milligrams a kilogram of total PFAS in the soil, in the source areas, decades on from the spills occurring. And those sorts of concentrations by regulation can't be landfilled, and most people are sending them off-site for thermal destruction simply because there's a very large mass involved, so it will bear the cost. We have several licensed thermal plants in Victoria using thermal desorption that can accept those soils and basically destroy the contaminants, and they can destroy them to a very high efficiency, say 99.99% removal of the PFAS, which generally allows you to reuse the soil. Soil washing, thermal desorption and thermal solutions are available in the US as well, of course. Soil washing has been trialled on site in Australia for PFAS. It can meet removal efficiencies of 95 to 99.9%, depending on the soil types involved and the concentrations involved, but it may not always get you down to a level where you can reuse the soil without management, in which case you might have to do immobilization of the treated soil. So that's probably not going to be a sort of a widely applied technology in Australia. Soil washing has also been used in the US and Europe, of course, for PFAS. Possibly the most widely used soil remediation technology in Australia when we're dealing with, say, medium levels of contamination So soil that you wouldn't send to landfill or for thermal destruction is immobilisation. Powdered activated carbon at a 1% addition with an iodine number of 900 or better will generally get you a leachability reduction of 99%. There are several other proprietary immobilisation agents available in Australia as well. If I said to you, I can remove 99% of your mass or reduce your leachability by 99%, you'd say, oh, that's great. Yeah, that's a good thing to do. But the question is, of course, how long will it be effective for? And we can't answer that immediately because we need to know in terms of a scale of hundreds to thousands of years. But there are several projects I'm aware of where people are taking soil that's been treated for at least a decade plus or minus, and with a range of amendments and looking at performance over that sort of time scale. So that's the big unknown, of course. I'm just going to scan down and see if there was anything different happening in the US from Bill's responses. Yes, one thing I noticed that was different that Bill said in the US, landfilling probably will not be a solution due to regulatory changes. So that was a significant difference. And possibly smouldering has been trialled for PFAS in soil. It was certainly being talked about a few years ago by Savron, but I don't know whether that's actually taken place at this stage. And that's me on soil.
Okay. And that kind of, again, leads quite nicely into the next question, which I'll ask both of you. And I'm interested to see how the regulatory difference might influence your responses. But I might start with you, John, just because I know you got your microphone there. What do you think is more important, reducing PFAS mass or reducing PFAS mass flux?
Well, thanks, Daniela. I guess somebody said to me, before you answer that question, you ought to explain what you mean by PFAS mass and PFAS mass flux. And that's not easy to do with a microphone talking to people. Generally prefer to write on the board, but let's go back to the media involved. Talking mass, you can have PFAS mass in, let's call them compartments, and those compartments will be soil, sediment, groundwater, surface water, and air. Now, most of us are used to dealing with soil and groundwater, and the big difference with PFAS is it's actually transferring into the surface water at the same sort of rate that it's transferring to the groundwater. We can forget about air in the context of this discussion anyway. So Peter Naderbaum at one stage put together, Peter Naderbaum from GHD, who's now semi-retired, he put together a scenario based on sort of a composite of about 20 or 30 airports he'd looked at with PFAS. And just to give you a perspective, in that composite scenario, our spill left 100 kilograms of PFAS in the soil, and 50 years down the track, there was about 0.1 kilogram of PFAS in the groundwater. And we think that there was about 1.1 kilogram of PFAS in the surface water as well. Estimating what's in the surface water is difficult because it's not like groundwater where you've got a constant flow. The flow changes over time, of course. But for perspective, 100 kilograms is in the soil, but only 0.1 is in the groundwater and another 0.1 in the surface water. So that tells you that if you don't address that soil mass, the problem with the groundwater and surface water is going to be ongoing. However, the exposure risk is through the surface water and groundwater. So in terms of priority, everyone is looking at the flux into the groundwater and the surface water. The second priority, of course, is to actually reduce the mass in the soil. Considering flux, because I said I was going to explain the difference between mass and flux, that's the rate of transfer of mass over time. And for our example, we had 0.1 kilogram in the groundwater, and it got there over 50 years. So at that sort of scale, the flux is 2 grams a year, which is a big generalization. So that's my explanation of mass and flux, and which is more important. They're both equally important, just in different timescales.
Bill, quickly, did you have anything to add to that?
Well, I appreciate that, and I think the key is the objectives and the risks and receptors all come into play as well. So I do think that the first things we're going to be implementing are going to be mass flux reduction solutions, whether they're pump and treat capture systems for hydraulic containment or barrier systems or injectable media, injectable polymers and carbon and other things like that to slow it down. But I do think, and a lot of the regulatory discussion, like what Andrew was covering too, I do believe, and I've worked both in Australia and the US, that the Australians are much more pragmatic, as are the New Zealand Kiwis. So I think in the US, and not to bash any of my my regulatory friends on the phone from ITRC, but we are a little more enforcement driven and a little more bright line. You must, if you have a number above a standard, you have to deal with it. And so we are protective of the receptors, but we also tend to want to go back to those source areas and eliminate that source material. That is the preferred direction. PFAS may rewrite how we do things because of the difficulties in treatment.
You're right. Some good points there too. Okay, well, I might quickly wrap up and move on to AFFF, just so we have some time to get back to the audience questions. And I'll introduce our two specialists for the AFFF theme. So joining us online from Queensland is Nigel Holmes. Nigel is a Principal Advisor for Incident Management for the Queensland Department of Environment and Science, which is the regulatory body for pollution management and incident response in Queensland. His role is statewide and provides advice on policy, standards, risk preparedness and response for incidents involving a diversity of hazardous materials. He has 30 years of experience in consulting and government roles covering the environmental, geotechnical and contamination assessment, regulation and policy development spaces for land, marine, freshwater and groundwater pollution assessment. And since 2012, he's been the coordinator for the Queensland foam policy and has also provided input to the Stockholm Convention's restrictions on the use of PFAS and Basel Convention technical guidelines for the destruction of PFAS waste. And joining us online from the US, we have Shalene Thomas. Shalene is the Vice President and Global Emerging Contaminant Program Manager for WSP. She has more than 20 years experience in environmental consulting and has been working on PFAS for the last 14 years. She has supported state, federal and industrial clients with PFAS evaluations, risk management and mitigation strategies. She also serves as WSP's PFAS workgroup lead and has supported PFAS projects in 32 states, spanning 9 of the 10 US EPA regions, as well as projects in the EU, Canada, and Australia. She currently serves as the AFFF leader for the ITRC PFAS stream and is a planning board member for the NPFA AFFF Fire Roadmap project. She has provided PFAS and AFFF training across the USA and has presented on the topic of PFAS and AFFF across the US, Canada, and Australia. Please welcome our two AFFF specialists. All right. Okay, I might start with you, Shalene. And my first question for you is, where does your country stand on the transition away from fluorinated foams and how is that progressing?
Well, I think when you look at foam transition across the US, you have to consider a few things. So one being the performance specification. It's either going to be driven by the performance specification or by regulation. And when you look at those two things, performance specification has been driving a large part of at least the impression and some of the transition in this country as it relates to Mil Spec 24385. So this is a military specification for AFFF that was put into inception by the Navy back in 1969. So it's been around for a very long time. In that MIL specification, it identified that AFFF under that MIL specification must have fluorinated surfactants in the neighborhood of 800 parts per billion. So until this performance specification changes here in the US, all military sites are going to have to use aqueous film forming foam or AFFF that contains PFAS. The FAA in the 70s, so that's our Federal Aviation Authority, they adopted this mill specification as well in the 70s. So now that specification applies both to our US Department of Defense facilities, as well as the Federal Airport Aviation, and specifically those airports that are considered Part 139 airports, which are the larger commercial airports with passengers. So there's a bit of a conundrum here in the US and a catch-22 where you have the specification that requires fluorosurfactants, but you have this need or desire to drive and change to fluorine-free foams. What the DoD or what the National Defense Authorization Act a few years ago did was require that the DoD write, pardon me, a new mill specification. That new mill specification is in draft right now. It's fluorine-free foam mill specification. It will be coming out as final in January of next year. Once it's out as final, then manufacturers can get their foams certified for that mill specification. There's about half a dozen foam manufacturers and foam products right now that are gearing up and getting ready to be certified under that specification. So once that happens, then all the Part 139 airports, of which there's about 550, all of the DoD entities, whether it be the hangars to the fire vehicles, which is about 4,600 locations, they can all then transition to fluorine-free foam. And in fact, that Defense Authorization Act requires the DoD to transition and stop purchasing or procuring within 2 years' time. So it's a fast and furious step forward for those two entities. If you look at other sectors across the US, whether it be oil and gas, chemical manufacturing, municipal fire departments, those that do not necessarily have to comply with a mill specification, they can transition, and many have started to transition. Of course, with things like municipalities, the challenge is funding. So what we've seen is several states, in combination with them deriving regulatory criteria or guidelines for foam transition, in that they shall not use foam, firefighting foam, for training. Most states that have any type of regulation or guidance have enacted that. What several states have done, though, is developed a take-back program. And they've allowed these municipalities and those that do not have the funding to get rid of their own foam through legislative funding at the state level, have allowed these take-back programs to happen. The states have collected them, any unused foam concentrate, and then have disposed of it. So we're seeing sort of a mixed review and a parallel timeline depending on where that driver is from a performance specification perspective. Some other good things, though, that are happening in that space as it relates to the transition for DoD and FAA. They're looking at and have recently completed an alternatives assessment. And in that alternatives assessment, they've actually identified a fit for purpose philosophy. Do you in fact need a aqueous film forming foam or foam of that performance standard? Can you get away with water? Can you get away with no foam? There's engineering flooring systems now that are out there that are also being considered for new builds. So it's opened up a whole perspective on how to transition from foam. You don't need to transition with another foam. You potentially could transition with other types of engineering controls.
And is there much guidance on how to do that transition from sort of like a decontamination or cross-contamination perspective?
I'm going to say no. If you look at a lot of the large multinational, international type firms, whether it be oil and gas or otherwise. DOD is working through that now. There is different levels of guidance that are being adopted, but not necessarily broadly accepted across industries or even within specific industries. So it's a bit of a bumpy path right now as everybody tries to transition, because there is not a single playbook. The NFPA, or National Fire Protection Association, their research foundation, we just finished a research project late last year, published early this year, taking all of the different fire user entities with the hopes of trying to collaborate and identify a national strategy for transition in this country, because it's going to be very challenging with everyone trying to do it at the same time to meet the different regulatory requirements.
Yeah, for sure. I mean, one thing I've observed from sort of witnessing it from the client's perspective is globally, there's very different views on how to do that transition from a decontamination standpoint, and lots of conflicting advice on what's adequate and what's inadequate. So I think it'd be good to see some progress in that space in the next few years. But I'm also interested to understand from you, so what are like the lawful options available for AFFF foams? You mentioned that there was a take back program, but what about sort of like waste products? What options are available for those sort of things, and how reliable, I guess, are those technologies?
So technologies are out there, nothing earth shattering as you would expect, probably similar to what you see in Australia with stabilization and burial, incineration, pardon me, and deep well injection. The US EPA pushed out a guidance document that everybody was waiting for with bated breath back in December of 2020. Sort of the guidance on how to manage waste related to PFAS, which is helpful also obviously with AFFF. That guidance identified those three options, but also identified more or less the do nothing option, which was store and stockpile until something better comes along. The DOD has struggled with incineration. They have a moratorium on right now where they are no longer incinerating until there's new information around incineration to prove that there's complete destruction of PFAS. Which we anticipate here by the end of the year. There's several entities putting out research around that. So hopefully that'll change rather soon.
That's great. Thank you for that very thorough response. Nigel, I'd be interested to hear if you've got a different perspective coming from Queensland. Like in your opinion, where does Australia stand on the transition away from fluorinated foams at the moment, and how do you think that's progressing?
Yes, good morning to everybody, afternoon and evening, wherever you might be. I'm in central Queensland, and I guess broadly Australia has had some success in transitioning from PFAS foams to non-persistent products. As Andrew said, essentially the states and territories are responsible for regulation of the sort of day-to-day operational activities. We don't have a federal EPA. There's more of sort of broad chemical regulation at that level. I think for Australia, transition has partly been driven by regulations in some states, very variable, but just as much driven by industry recognising their liability. I guess in some part we made sure that we put out all our reasoning behind why we wanted people to transition and what the content of the Queensland firefighting foam management policy was about. My involvement with foam more broadly, and especially PFAS, that began back in 2011 with Dr. Roger Klein of Cambridge and Dr. Jimmy Seow of WA. Some of you may know these people, and I also need to acknowledge there were many other experts who provided advice when we were developing the policy. I guess I'm not exaggerating when I say that a lot has happened since then, and it's great that we are in the position that we are now compared to the very sort of nervous position we were in back in 2011-12. I guess broadly, most fire brigades across Australian civil airports have transitioned to non-persistent foams long ago, as have a lot of industry users. For example, the Queensland Fire Service transitioned back in 2003, well prior to any thoughts of policies. So did the Victorian Fire Brigade in 2009, Australian Civil Airports in 2010. So there's been a sort of general progression as individual entities have recognised the problems, as well as it being more consolidated into policies and even regulation. So some legislation has had to be amended in states and territories. For us, it was simply to put in place a policy that explained what the Environmental Protection Act required of any contaminant. So PFAS are nothing special in that regard, but it was clearly something that needed to be specifically identified and dealt with. So in 2016, Queensland had foam stocks of about 750,000 litres, maybe a bit more, of which about 94% were PFAS when we did a bit of an audit and query of the various larger users mostly. And the Queensland policy was mostly about transitioning to non-persistent foam and was developed over 2014-15. So it wasn't just about PFAS, it was about firefighting foam use generally, and obviously that big focus on PFAS. The policy came into force in 2016 with a 3-year general transition period or grace period. It was basically saying what the Act had already required, and it was giving people time to come into compliance with the various provisions of general environmental duty and possibly license conditions as well. We certainly looked very broadly at the considerations in developing the policy and took into account the foam effectiveness, the cost, the practicalities, the timelines for the different end users. There was a lot of industry consultation about all of that, and consultation with all sorts of experts and the other states, of course, as well as considering the health, socio-economic, environmental factors which we're obliged to look at under our Environmental Protection Act in Queensland, and more broadly the Intergovernmental Agreement on the Environment when it comes to things like a precautionary principle. Policy development was in the light of limited but significant emerging information about PFAS. As I said, we were pretty nervous about all of that because back in 2011-12, when policy was being considered, things were looking to match up with the precautionary principle pretty well and requiring action, but how far we went was the big question. Since then, we've grown from a focus of PFOS and PFOA to recognising PFAS as a class, and I think that's a really good thing, because as I think a number of people have said over time and in these sessions, that if you just change a fluorine for a chlorine, you can have a totally different chemical, and that was the way that we previously looked at such things, and that's a mistake, because at last count there was about 9,000 different PFAS of similar or unknown risk at the last count, the Stockholm Convention, and from various other sources. In Queensland, most foam users are small scale, and they transitioned in the first year of the policy over 2016-17. So there wasn't a big deal there. It wasn't as though we gave them 3 years and they went back to sleep for 3 years and then did everything at the last minute. A lot of them said, yeah, okay, we have a liability, we need to move on, and we need to do something about it. There were those large facilities that needed more time, and in Queensland there are only sort of 4 of the very large facilities, mostly the big fuel tank farms. And they needed a bit more time after the 3-year transition period. And the way we dealt with that was temporary environmental licenses were issued with timelines, with milestones and all that sort of thing, which have largely been met. I think we've only really got one outstanding at the moment. And mostly that's been about the development of suitable foams for those very large tank fires. So to recap, from an initial 94% of foam being PFAS, now in 2022, we've reversed that with 92% fluorine-free or non-persistent foam. I emphasise non-persistent because there's talk of siloxanes and all sorts of other things, so we'd rather not have a regrettable substitution of one problem for another, for an alternative PFAS, if you like. The remainder of PFAS foams in Queensland is about 58,000 litres, all at fully contained large fuel terminals, so the risk is pretty low of any sort of release. And most of those facilities have transitioned most of the foams on their site, so all of the sort of smaller quantities and where there isn't an appropriate foam available, except for their very large fuel and crude tank systems. But we're expecting replacements with certified fluorine-free Newtonian foams within a year. So we're pretty happy that transition has gone pretty smoothly without any great dramas. So to outline the approach that worked for us, despite the limited information initially, back 2010, 2015. Transition away from PFAS foam largely sold itself once there was an understanding of the liabilities and costs for industry and the community. There was certainly political concern once things started to emerge about site contamination and water contamination. Plus, there were legal obligations of precautionary principle in legal precedents, legislation, and also from the Rio Convention. We found the key to timely and effective transition was reaching a common understanding, excuse me, of the liabilities faced by regulators and industries. It was very cooperative and open, sharing information and perspectives. We produced explanatory notes, laying out our entire thoughts about why and how. And we had that balanced view about safety, performance, cost, health, environment, and all the sort of issues of surrounding it. So it wasn't just a environmental or health focus. The transition priorities were set according to risk. So we engaged with industry very closely to sort of say, okay, you might have very big stocks of a certain type of PFAS foam, but what are the real risks of that release? And for the most part, with fully contained facilities, it was a case of changing procedures or putting in place some modifications. And taking into account the practicalities of transition for each industry really was key to get them on board, to get their cooperation. And setting those achievable goals and timelines for transition really helped us to understand the issues faced by industry, and industry understood what the real risks for them were, because let's face it, their business was not foam. Their business was making something or refining something. So they were a little bit in the dark about the why. So that's why we engaged at a very detailed level. We certainly spent quite a bit of time busting myths and breaking old habits. There's a whole lot of resistance for various reasons, and a whole lot of misinformation from rumours and distortion of the facts, let's say. So we really aimed for a realistic transition timelines and goals that balanced all of those things, like the risks, the costs, and the practicalities. So identifying and engaging with all the foam interests and users, large and small, so that's the manufacturers, the suppliers, the end users, the waste industry as well. Determining the fluorine-free alternative foams were viable for each use, so that we had to get up to speed on what was practical and what wasn't. So I certainly came to understand foams very closely through Last Fire and other organisations. There had to be physical or procedural interim measures to reduce risk. So that's mostly for bigger facilities or change-outs that were a priority. So for example, if you had a wharf where it was impossible to contain the foam, well, that was the highest priority for changeover, because if they had an incident, then it was going to go straight into the waterway. And of course, early on in the piece, I thought about the PFAS disposal options, going, well, we're going to have a whole lot of foam that needs disposal. How simple or difficult is it to dispose of? And of course, PFAS is very difficult to dispose of. So we looked at facilitating new technologies. Thank you.
No, that's great. Thank you very much. That's a very thorough response. Lots of good things to think about there. I've seen a few people writing questions, so I'm just going to wrap up there just to make sure that we can filter some of those questions back. But just very quickly, I just need to hand over to Rebecca Higgins, the co-chair from ITRC, who would just like to share some new information about a pilot technology being trialled in Australia at the moment.
Oh, thank you. Hopefully you can hear me just fine. Good morning over there. You're not the first Australians I've spoken with today, so if that makes you feel any better. The reason I have spoken with Australians just today is because here in Minnesota, under our East Metro unit work, which is conducting a feasibility study for the 3M settlement that we had for 2018. You might have heard of it. It was an $850 million settlement between the state of Minnesota and 3M. And as part of that settlement, we are tasked with conducting a feasibility study and source assessment into PFAS transport in a certain portion of the East Metro. And now we've worked our way through the last 3 years through that feasibility study and have come to the point where we're starting to test technologies for cleanup of any given different media. In particular, we're starting with groundwater and surface water remedial technology deployment, and we're testing the first couple of different systems. One is the surface activated foam fractionation system, and that is a system out of New South Wales in Australia. And our big blue bubbler, as we'd like to call it, has arrived, and it is finally here. It is safe, and I just got the phone call a few minutes ago that there are no components injured in its transport. So things can be made there and made it all the way here to Minnesota. We're going to put that out in our East Metro, and we're going to first see if we can't use it to do some foam fractionation of our groundwater and then surface water. Then we're going to take that hyperconcentrate out of the staff unit, and we're going to put it through the first of what will be ultimately several different technologies for, I will call it transformation and reduction, if not destruction. So if you're familiar with, any kind of destructive technologies, I think the key message here is that it's much more about transformation and reduction, and not so much guaranteeing that you're going to get rid of all PFAS of all forms, especially when we can only detect in the order of 40 to 50 out of the 10,000 plus. So we're going to deploy these technologies in a treatment chain approach, and we're going to see how it works. So this is just getting on its feet now, and literally deploying this in the coming 2 to 3 weeks out here in the East Metro. And we'll keep everybody, stay tuned for our results, I guess is the best I can say.
Thanks, Rebecca. That sounds awesome. I'm sure we'll all be looking to get an update on that when you're ready in due course. We do have some questions that have come through. The first question's from online, and it's for our Australian speakers. And the question is, do airports in your country currently use AFFF? What specifications drive the requirements?
Nigel, do you have a comment on that?
Yes, I can comment on that. Sorry, go Andrew.
No, over to you, Nigel.
Okay, yeah, it's quite simple. If we have a civil airport, they can use whatever foam they like, and they transitioned in 2010. Air Services Australia drove that. If they were a military or are a military facility, and there are only a few around Australia, then they were required under defence to use an AFFF. I think in 21-22, Defence have transitioned to fluorine-free, or in the process of doing so right now. Thanks.
Nothing to add?
No, so there's joint user airports in Australia with Defence and Civil, and they were using a fluorinated compound, but Defence has had a massive transformation program, and they've started with their vehicles, then through their installations. I don't know the latest, but I believe that it's about finished.
All right. Next question. I might throw this one to Kristi. It's another online question. And the question is, do you anticipate PFAS being regulated in sediment in any states in the near future?
What I can say about that is that we've got lots of regulations in states in the soil and water table that's updated that I mentioned, that there's a link in the chat box. It doesn't have sediment yet, but I know that a lot of states are curious about sediments. So I wouldn't say in the near future, but definitely something that states are looking at.
Okay, great. And I guess while I've got you, another question for you, Kristi. The WHO recently released draft drinking water guidelines, which were significantly higher than the US EPA values. Do PFAS recommendations from other parts of the world impact or influence guidelines in your country? And if so, how?
So the short answer is not really. And as far as the WHO release, I know that there have been a lot of comments submitted on that publication, but in general, no, there should not be any impact to our regulations here in the States.
Okay, thank you. John, this one's for you. You still awake? All right, so Dr. John Hunt, you mentioned thermal sites in Victoria for PFAS destruction in soil. Are you familiar with destruction at cement kilns in Queensland? Any thoughts on how these compare?
I believe that PFAS is being destroyed in the cement kiln in Queensland, and I can't comment beyond that.
That's an honest
I can certainly
answer.
comment on that.
Okay, that sounds good because the next question's for you anyway. So why don't you quickly comment on that and then I'll ask you another question, Nigel.
Okay, yeah, very simply, in the early days, we realised there was going to be a lot of PFAS waste. We had a plasma arc furnace which can only burn very pure liquids through basically a diesel nozzle, so no chunky bits. So we looked at cement kilns as an option, and research showed that calcium will catalyse destruction of PFAS at much lower temperatures than the typical 1100 degrees Celsius that you hear. So we ran trials in 2016-17, and we found complete destruction. Basically, the calcium, which is huge amounts in a cement kiln, a ratio of about 750 to 1 to the fluorine, scavenges the fluorine as calcium fluoride, which is inert, insoluble, non-toxic, and unless you use sulfuric acid, can't be brought back into use. And the trials showed no PFAS in emissions or in the cement clinker. So it's got very wide safety margins in just out of pure luck. So it's a great way of disposal. You can dispose of liquids and solids, mostly the liquids that are injected in combination with the alternative fuel oils, the waste oils, basically. Thanks.
Okay. And next question for you, Nigel. How does foam transition in Queensland compare to other states? Do you see other states making use of the Queensland foam policy since it has one of the few guidance values for milligrams per kilogram for PFAS in new foams?
Yes, we certainly took a stab at that early on to say there's likely to be contamination in existing systems, and we need to make provision for that. So we consulted with the manufacturers about cross-contamination on facilities mostly overseas to say, well, what could they achieve? We also looked at what was already in place. I think it was in the UK and Europe for the 10 milligram per kilo of PFAS, and on that basis came up with 10 milligram per kilo of PFAS plus hexane sulfonate, and we've expanded that to all sulfonates now that can be analysed for, as well as the 50 milligram per kilo of fluorine in systems. What's being achieved with cleanouts is far, far lower than that. So we haven't had a need to tighten up that as yet. We have amended the policy in 2021. So we found that the cleanouts have been very good because people are very nervous about cross-contamination, having to dispose of a whole lot of new foam. So the cleanouts have been good, and the cross-contamination in new foam that's coming in is minimal. In fact, people are using distilled water to produce their foam in some countries. And what's coming into play is cleanouts that are more and more effective with solvents and recirculation to free up the PFAS from all the different surfaces in the system. So there's been quite a lot of development in cleanout as well. Thanks.
Thanks, Nigel. I've got one more question for Kristi. I've got one question for Andrew, and then if we've got time, we might loop back again on foam. So Kristi, are secondary sources, wastewater utilities and landfills treated differently from a regulatory perspective than primary sources?
Federally, I can't speak to that per se, but at least in Vermont, we are looking at landfills and monitoring them. As far as are they treated differently than a primary source, I would have to get back to you on that.
Okay. Andrew, I've got a question for you. If you could change one thing about the way that we regulate PFAS, what would it be?
I think I might have covered that. I mean, to answer Kristi's question for Australia, I've seen them regulated the same way. So at the moment, we're regulating primary and secondary sources and tertiary sources the same way. And we're getting a bit, I think, muddied about what really matters. Yes, it's definitely a problem that we have so much PFAS in the environment, but tackling ambient or diffuse or background PFAS is not the solution. We need to work out what we can tolerate. So if there's one thing I could change, this is really aimed at the circular economy, where I do a little bit of work at the moment, is what really is an acceptable or allowable amount in the circular economy. We have, just as an aside, the PFAS content of bagasse food packaging. If you buy a salad in a waterproof bowl that's compostable, there's 10 to 50 parts per million of total PFAS in that container. And we are encouraged to compost it. And where does that going to end up? So if we're not going to tackle the chemicals regulation perspective, at least work out what is tolerable with respect to background, so to speak, background PFAS in the environment.
Mm-hmm. That's a good one. All right. Can I thank our speakers for joining us today? And I'll hand back to Matt for the official close.
Fantastic. Thanks everyone for joining, both in the room and online. And a huge thank you to all our speakers. A lot of work goes behind the scenes to make this happen, and also especially to Danielle for making the time to chair the session today. There will be a questionnaire that will go out. I think it's in the chat, and will also be emailed to all that registered, and so we'll send that to those in the room just to provide feedback in relation to the event today. As we said, this is the first of hopefully many of these type of conversations that go on, not just around PFAS, but around a range of different topics within our industry. And we're keen to get your feedback in relation to what other things and topics you'd like to hear about as we move into next year and look to put on more events. Into next year, we are looking to hold a 1 to 2 day workshop on PFAS that will be held in the end of April, led by the Emerging Contaminants Specialist Interest Group. And we're looking to get ITRC out in person for that event. We're also looking to launch, obviously, Eco Forum, SUSREM 23, back in October of next year. So that'll be in Melbourne on the week of the 9th of October. And again, we're looking for ITRC to be present at that particular conference. So once again, thank you all. For those in the States, enjoy your evening. And for those in Melbourne, enjoy the rest of your day. Thank you.